My name's Hussein Jirde. I started working at Rangle almost exactly a year ago. And today I want to talk about building progressive web applications. We're going to touch up on so everything we do touch up on today can apply to more than just Angular. But I'm going to focus on a few libraries that Angular provides, such as the service worker library and so forth. So before we go into details of what makes up a progressive web application, I want to talk about mobile for a bit. I think it's safe to say that the vast majority of us in this room own a mobile device of some sort. Now, what we do on our mobile devices can vary day to day, but there's no denying that the amount of time we spend on our smartphones and tablets have only increased year after year after year. So according to ComScore, in 2017, the average user spends 16 times more time on popular native apps than they do on the mobile web. So as consumers, there's no denying that we spend a lot more time on native Android and iOS apps than the mobile browser. But funny enough, mobile web pages still received over 2 times more unique monthly visitors than native apps. And this is huge. This just shows we spend a lot of time on the web, even on our phones. So how can we make sure that the users who experience our web pages have a great experience, regardless of what device they use? We can sort of continue building the same apps and web pages like we currently do, but we can think of adding a number of key ingredients up on top. And that essentially is what a progressive web application is. In short, progressive web applications, or PWAs, use modern web capabilities to provide a reliable, engaging, and fast user experience. And the idea is it does this on any device. If we're thinking of adding all these key ingredients or sprinkling different technologies on top, it's probably a good idea of using some sort of tool to measure how well we're doing. One such tool is called Lighthouse, and it's built by the Google Chrome team. You can either install the Node CLI or use a Chrome extension. I prefer using the extension because it's a lot simpler, and all you need to do is on any web page, actually just pressing the extension icon will run a number of tests on your page. After a few minutes, it'll actually generate a report, and you'll see that in a bit. The report actually gives you a score on how well your page is doing. It'll tell you some things that you failed, as well as things that you're doing well. So it's a nice way to gauge how well you're doing in terms of progressive enhancements. So for the rest of this talk, what I want to do is sort of focus on what Lighthouse, or some of the main things Lighthouse checks for when it tests your web page. And the very first thing that it actually looks for is that if your web page is on a secure network connection. And you can do that by just using HTTPS. So it's important to make sure your web page is secure to prevent man-in-the-middle attacks and so forth. But there's a lot of progressive technologies, such as service workers, which we'll talk about in a bit, that don't work unless your web page is served with HTTPS. Another thing Lighthouse also checks for is, can your website or application work well without an internet connection or with a poor internet connection? I think a lot of us here are quite familiar with seeing the dinosaur from time to time, and we see this when we're using Chrome and we don't have a working network connection. So one thing that we can use in order to prevent us from seeing this is something called service workers. So a service worker is a script that runs in the background of your browser when you view a web page. So how do we add a service worker? We can create the file and write the logic ourselves, or we can use a library to make it easier for us. One such library is called Workbox, and it's also built by the Google Chrome team. You can install the CLI globally, and then you can run a simple generate SW command. And when you do that, what actually happens is that it asks you a couple of simple questions. What is the root of your web app? If you're building an Angular app, you're most likely using a module bundler like Webpack, and you most likely have a final deployed folder location. The next question is, which file types would you like to cache? You can specify if you want to cache all your file types or be specific in which certain files you only want to cache. The next one is, what should the path of your service worker file live? You most likely want to make sure that that lives in the final folder that gets deployed. And the very last question is, do you want to save these settings into a configurations file? So if you answer yes to the last question, Workbox knows to not ask you these questions again and again if you actually run the generate SW command. It knows to use the answers on that configurations file instead. So as handy as it is to just run a generate SW command and get a service worker up and running in about 30 seconds, the only issue here is that we'll need to make sure we run this command every single time we make a change to our application. For example, if we remove an image or if we add another file, we want to make sure our service worker is up to date. So another thing you can do is you can actually install it as a dev dependency instead, and you can have the generate SW command as part of your build process. So every time you make a new build, your service worker will always be up to date. So that actually creates the service worker file where we ask it to, but we still need to tell the browser how to register it. And you can do that by adding a script tag in your index.html. The very first thing you can do is check and see if service workers actually exist in your browser, because they're not currently supported in all browsers. And if they are, you want to make sure that you register your service worker after window on load. You don't want the window on load event to contend with service worker registration. You can register your service worker by running navigator service worker register with the location of your service worker file. And if you like, you can have console log output to say it's been successful or something must have failed. So we've talked about how to install a service worker, and we've talked about how to register one, but we really haven't talked about what service workers actually do. So the very first thing you can think about is service workers allow you to pre-cache your application shell. So like the name suggests, your app shell is the shell of your user interface. It's the header, it's the loading icons, it's the footer, it's everything that doesn't hold actual real content. The way service workers work is that they act like a middleman between your browser and the network. When you load a page for the very first time, you could tell your service worker to cache the JavaScript, the HTML, and the CSS that make up your app shell. And when you reload the page for a second time, your service worker can now know to just give those files to the browser rather than having going all the way to the network. So you're getting much faster repeat visits. Another thing service workers also allow us to do is they allow us to pre-cache the results from dynamic content. So we can actually have real data pre-cached, so if the user is using their phone without a network connection, they can see older data rather than no data. So it's the combination of an app shell and dynamic caching that allows for two things: faster repeat visits and the possibility of offline support. So this is a pretty useful tweet that I actually saw recently by Henrik Jorateng, and he was one of the few consultants that worked on the Starbucks PWA that they launched recently. It's still in preview mode, but it's actually a really nice app. And when I saw this, it stood out to me because every time I talk to people in general about offline first and offline support, a lot of the responses I hear are, do I really need to think about offline support? All of my users are going to be having an internet connection. So I think it's more than just offline first, it's reliability. And the idea is if somebody's using your application all the time, chances are they are going to try to use it when they have a poor network connection. They might be on the TTC, they might be on airplane mode, there's a number of different reasons. So Workbox does make it extremely simple to create and register a brand new service worker regardless of what tool or framework you use, but Angular actually has its own library to make it even easier, and it's called Angular Service Worker. So if anybody here has actually tried to build an Angular app, the CLI makes it a lot easier, and it's a command line interface that lets you build an Angular app and not worry about build configurations, as well as scaffolding and everything else is quite easier. So the 1.6 release, which is quite recent, actually allows you to create a brand new app and have service worker functionality baked in by default. So if you want to install a CLI, you can just npm install Angular CLI latest. And when you're generating a brand new app, you can add a -- service worker flag. And what that does is when it generates your final application, and a lot of Angular apps actually have an Angular CLI JSON file that has a number of configurations for your app, there's a service worker flag that's now enabled to true. So the ng-serve command is what you can use to actually get a web server up and running. So whenever you're building an Angular app, it's easy to use ng-serve to have live reload and see your changes happening in real time. But you can't have service worker changes actually reflected when you use ng-serve. You either have to use a separate HTTP server, or you can actually build a production build. So ng-build creates a final build, and adding a prod flag creates a production build. So with service workers baked in, what happens now is that there are two new files actually created in the final folder. One called ngsw worker, and one called ngsw. ngsw worker is actually that service worker file, while ngsw are the final configurations specified for you to take a look at. What also gets added in your app module, which is the root module of your entire application, is a brand new service worker module that comes from Angular Service Worker. And in the imports, you can see that it actually registers that service worker file, ngsw worker, and it already has it enabled only on production builds. So like I mentioned, Workbox creates a brand new configurations file that allows you to modify settings for your service worker. Similarly, Angular Service Worker lets you do the same thing. There's an ngsw config file that actually exists in your source directory. And here you can actually specify what files you want to cache or how you want them cached. The very first thing you most likely want to specify is where your index.html lives. The next thing is an array of objects called asset groups. These are all the groups, or the groups of assets that define static resources. In other words, here is where you define your application shell. For every asset group, besides giving it a name, you can give it an install mode attribute. Now, install mode tells Angular how you want those files pre-cached. You can specify pre-fetch, or you can specify lazy. Pre-fetch is telling Angular, please get these files cached as soon as possible. So even if you're on an initial route, for example, it could be a bundle file, it will automatically cache that file even if it's on another route. And the idea here is you know it's high priority, and if the network connection happens to fail, the user can still see that asset. While lazy is actually more specific to things that you might want to cache only when they're requested. So for example, if you have a number of different images for responsiveness, you probably don't want all of them cached using prefetch. Lazy makes more sense, so only when the user actually does the request, or the browser does the request for that image, the service worker will know to actually cache it. And finally, you also want to specify what actual files you want to cache. So there's a resources object with two separate arrays, one called files and one called version files. The only difference here is files are simple static globs, while version files are actually files that already contain a hash with them. Because this is using Webpack, bundle CSS, bundle JS, and all the chunks actually out there all have hashes. So another thing, like I mentioned, is, again, dynamic caching is also something that you can make sure service workers allow you to do. And you can do that in the same file by defining a data groups array. You can cache your dynamic resources by defining your URLs, or all the URLs you actually want to make sure that it actually gets cached, as well as you have more fine-grained control by defining a cache config object. Max size defines the maximum number of entries you want cached. Max age is how long you want the results of this dynamic resource cached. Timeout is if you want to add a timeout. And there's also a network strategy attribute. The two values there is either freshness or performance. I love the term freshness. I love that they actually chose that as part of their API. But the way it works is freshness is a network-first strategy. Every time your service worker actually hits this specific dynamic resource, Your service worker will know to always update its results, its cached results, with the latest data. So if your service worker if your network happens to fail, you get to see the latest data that your service worker cached. Performance works in the opposite way. It's a cache-first strategy. With performance, your service worker is always going to give its results, but if your service worker fails, then rely on the network. You most likely only want to use a performance strategy if you know the data for your app probably won't change in the future. Another very nice thing that Angular actually provides, an Angular service worker, is it allows you to check for service worker updates. And the reason why this is important is if you consider the scenario where you're building an application, you have a service worker and you deploy it, and users who are using your application right now have a service worker on their browser actually serving cached resources. Now, if you make an update to your application on the server side and deploy that, users don't see your change. So the nice thing about Angular Service Worker is that it actually gives you an SW update class that you can actually use and subscribe to check for service worker updates. Once you import that, you can easily just say there's an available operator that you can subscribe to, and whenever that actually fires, you can do something or do anything with a service worker update. A good example is if you happen to be using Angular Material, there's a nice little snack bar UI element that you can use that shows a little tooltip-looking thing that pops up at the bottom of your screen. And the nice thing about, for example, if you're using this, you can easily show that snack bar with a message that says new update available. Do you want to reload with a button that says reload? And whenever the user actually presses that or on that action, you can actually reload your entire window. Another very useful thing that service workers also allow you to do is they allow you to deal with push notifications. Angular also has a class for it, and it's called SW push. So can we use service workers right now? Fortunately, Chrome, Firefox, and Opera all support service workers. And if I'm not mistaken, I think it was 2 weeks ago, Edge and Safari both announced on the same day that they're currently supporting it in preview mode. And that's amazing, because we know eventually, or pretty soon actually, it can be supported in all major browsers. So another thing Lighthouse also checks for, which is quite important, is if the page load of your application or your web page is actually quite fast. Now, the thing about cutting down page load times is that there's no one right way of doing it. A lot of people have different techniques and a lot of different ways to make sure that their app loads as fast as possible. And I'll just go over a few that you can consider. The very first one that you can think about is something called link preload and link prefetch. So these are simple link HTML tags or link HTTP headers that you can include in your application, and they allow you to actually define specific resources that you want to tell the browser to prioritize. So if you're using prefetch, you're telling the browser, hey, please prioritize this resource as much as possible and download it as soon as you can. Now, you're not going to get the most bang for your buck if you're using prefetch for resources already defined at the head of your HTML. You'd probably get bigger gains if you use it for something the browser might notice a little later. For example, a CSS or font file tucked deep in one of your CSS files. Preload works in about the same way, but it's for resources at a different navigation route. So if you add a link preload header to your HTML, you can tell the browser, hey, this is important. Please try to prioritize this as soon as you can, but it's not as important as the resources needed for the current route. So the browser will try to download it only when it takes care of other critical resources. Another thing you can also think about is something called H2 push. So HTTP2 aims to provide a number of performance improvements over HTTP1. But there's one specific one called server push. And the idea behind server push is that you can define or you can set a number of resources and tell the server to give those resources to your browser before the browser even makes the request for them. So you can get very fast first page loads. However, a lot of people have noticed that it's still an experimental technology, and using H2 push for all of your assets, let's say all of your JavaScript files or all of your CSS files, it actually causes a performance hit. So it's something that you might want to try carefully, but it's still something you can't rely on fully just yet. But another thing you can actually think about when you're building Angular applications is something called code splitting. And the idea behind code splitting is instead of giving the user the entire bundle on the initial route, why not give them what they need incrementally as they make it through the other parts of the application? So someone was nice enough to actually get the final output bundle sizes for a number of different JavaScript frameworks and libraries for just simple hello world applications. And some actually had 4 kilobyte output sizes, and others went all the way up to 200. Now, there's a number of different reasons why different frameworks and different libraries actually have much larger or much smaller bundle sizes at the very beginning, but it's something to think about as you're building your application. I think a lot of us here who build front-end apps with Angular or with anything else is that we're making things a lot more client-side heavy, and that comes at a cost of larger bundle sizes. So again, the concept of code splitting your routes only when the user actually navigates to their specific actual pages is called lazy loading. With Angular, lazy loading is actually built into its routing framework. When you're defining your routes, you can define your path as well as the components that make that route, but you can also add a load children attribute to specify a specific module to only load for that route. So for example, here, if I had this in my application, Angular would know to not actually load the details module until the user makes it to the details route. So another thing Lighthouse also checks for is, can your website or your web application be installed on your mobile home screen? And you could do that by adding a web app manifest. So the way that works is you can add a simple link tag to your HTML and define rel manifest and define the file location for that manifest file. And the way the manifest file looks like is it's just a simple JSON. You define a name, you define short name, you define a number of icons with different images for different device screens. For example, an Android tablet is going to need a different home icon than, for example, a small smartphone. And you define theme colors, background colors, display, and orientation. And the way it works is browsers that actually support a web app manifest, what they'll do is when the user actually navigates to the website in a number of different times within a specific window. So I think with Chrome right now, the user has to actually open the page twice within 5 or 10 minutes. What pops up is an actual install banner. And that banner says, hey, do you want to add this to your home screen? And the reason why this is handy, it's because a lot of us are not thinking about installing websites into our home screen. So this is sort of a prompt to tell the user that, hey, you can actually install this and add this to your home screen, why not give it a shot? And when you do, what you see is a simple icon on your home page that actually looks like any other app. You can't tell whether this is a web app or a native app at this point. Actually pressing the icon will load a splash screen while your JavaScript bundle is actually loading. And when your app is actually loaded, you get a full screen experience. You don't get that URL bar up top. You don't get the back icon, the front icon. You get more of a native app feeling. So can we use web app manifests? Currently, only Chrome and Opera support web app manifests. Edge and Firefox are both currently developing for it. So Safari on iOS, I think a lot of us here probably own iPhones. I own an iPhone. You can always install any web page on your home screen, but there's not much more to it. But what you can actually do is that iOS actually supports some meta tags as well as link rel Apple Touch icon tags, where you could define that you only want to see the little status bar without a URL bar. You can even define the color of your status bar. And when you define your icons, you get somewhat of a similar experience. You see the icon on the home screen, you can actually press it and you get a full screen experience. Keep in mind, this is Safari on iOS, and service workers aren't supported. So you're not going to get offline support when you're actually using this right now, but you can at least get a full screen experience on any page. So again, the idea behind progressive web is that it's not one specific tool or technology. It's a number of different techniques you can apply to your page in order to make sure your app or your website loads as fast and as reliably as possible. I think there are two important metrics that need to be sort of explained and thought about when you're thinking of progressive enhancements. And they do relate to page load times. One being first meaningful paint. And that's the time it takes for the user to see actual meaningful content when they load the app for the first time. Time to interactive is when the JavaScript thread settles and your user can actually navigate and use your application. Now, I see a lot of different statistics for time to interactive with mobile phones like a Moto G4 and on throttled 3G or emerging market connections. And the reason why people use those throttle conditions is because we've all become accustomed to building our applications on powerful MacBooks and powerful desktop machines. We don't think about how our application loads on a poorer device with a weaker network connection. So one statistic that I saw recently said that time to interactive on average for mobile phones on poorer conditions is 16 seconds. I saw another one that says 19 seconds. And the more numbers I see, the crazier it gets. I think one thing to think about is if your application takes longer than 5 seconds to load, a lot of your users will probably give up. It's another super useful tweet that I actually saw quite recently, and when I saw this, it kind of spoke out to me. And the thing is, when I talk about progressive web applications to people in general, I think the most people who are excited about it are developers. There are people who are actually building the application themselves. But I've yet to meet many people who don't actually do development who are excited by the idea of installing apps to their home screen or getting an offline experience on a web app. And I think it's something to think about as things are improving in the landscape. The only opinion of PWAs that people I think should be more interested in are people who don't know what a PWA is. Another thing I do want to talk about is whenever I do mention progressive web applications, there are a lot of similarities to native apps, right? And I think a lot of the good things in native apps are coming to the web, but they're not the same thing. I think a lot of people will eventually ask and they'll say, hey, will progressive web apps eventually replace native apps? Can they be reused as a replacement to native iOS and Android apps? And I think it's not a fair judgment. It's sort of comparing apples to potatoes. It just doesn't make sense. They're two completely different things. The idea about progressive web apps is why not continue building the apps you currently build, but just adding these newer technologies on top. And this is an expression that I sort of think about when people say progressive web apps will eventually replace native apps. My name is Hussein Jerde. I hope you guys enjoyed this talk as much as I enjoyed giving it. You can reach out to me anytime. I'll be here for a bit to answer questions as well. Thank you.